Okay, we are solving by factoring today. So as the name suggests, we're going to need to know how to factor to do this. So there's lots of steps to this, but mostly it's the same stuff that we did on Friday. So step one is to make sure your equation has an equal to 0. There must be a 0 on one side of the equation. Can you go ahead and put your phone on your bag, please? Thank you very much. It must be equal to 0. So this first problem's already got that first step done for it. Our next step is going to be to factor this thing. So I want to factor it and make it look like we did with our work on Thursday. There's still going to be an equal 0, but I'm going to rewrite it in factored format. So we've got to go through all those steps that we were doing on Thursday last week just to get it in this factored form. So remember, there are like 6 steps. So first thing we did was identify A, B, and C. In this problem, A is 3, B is -19, and C is 6. Do you guys remember finding A, B, and C last week? What did we do next last week? We made a diamond problem. So let's build ourselves a diamond. An X. Way back at the beginning of the year, and last year in Algebra 1, you saw problems in your book that look like this. That's why they call them a diamond problem. I don't draw the kind of rhombus around it. I just draw the diamond. So that's why I still refer to them as a diamond problem, because I'm kind of envisioning a diamond around this thing. I'm just too lazy to draw it. So we could call it an X. We could make an X problem, however you want to call it. All right, so it's A times C on the top. Always whatever A is times whatever C is. So A times C for our problem, that's 3 times 6. So we got an 18 up top. And then B goes in the bottom. For our problem, that's -19. And our job is to find the 2 side numbers. Those 2 side numbers should multiply to give you the top number. They should add up to give you the bottom number. So what 2 numbers multiplies to give you 18 adds up to -19? -18 times -1 is +18. And if you add them, you'll get -19. Perfect. Right. The diamond's done. Now we go on to the box. And we have to do the box because A is not equal to 1. If A is equal to 1, there's a bit of a shortcut, but it's not, so we don't have a shortcut. So we'll just go into the box. So drawing my box down here. And we need to remember where all the pieces of our box come from. Remember, these 2 corners come from your original quadratic. So 3v squared is going to go there. That's our first term. Last term was 6. That goes down there. The other 2 corners come from our diamond or X. And because they're coming from the X, they need a variable. Our variable is V. So we're going to have -18V and -1V. -18V, -1V. If you put the -1V here and the -18V here, that's fine. You don't want to flip these 2. You can actually, but it gets a little confusing when you do. These 2, you can flip them though. Now the next step might look a little bit different for you, but you'll end up getting the same answer I do. All right, any questions up to there? All right, so what we did on Thursday, and there's a multitude of ways to figure out what goes on the outside here. My favorite way is to focus on the top row and do a GCF. What is the biggest thing that we can divide out of 3 and 1? The biggest number that divides into 3 and 1? 1. And how about variables? Can we divide V's out of both of them? What's the biggest number of V's we can get out of both of them? Just a single V can come out of both of those. So we've got that 1V out in front. That's just our GCF. Now we're going to put a couple terms up top here. And whatever those are, they should multiply by that 1V to give us our top row here. So what would I put up here? So when it multiplies by 1V, it gives me 3V squared. 3v, let me double check that. 1 times 3 is 3, v times v is v squared. Yes, that is correct. What could I put up here so that it would multiply by 1v to give me negative 1v? Negative 1, agreed. And then I got one more spot down here. Whatever this is, it should multiply by that 3v minus 1 to give me a negative 18v and a positive 6. Let me check 6. 6 times 3v is positive 18v. So let's change it to a negative. Negative 6 times 3v is negative 18v. Negative 6 times negative 1 is positive 6. Yes, that works. So all of that work, all of those steps, just to factor this equation into this equation. 3v minus 1 and 1v minus 6. It's a lot of work, and we still have a couple steps left to go. Yeah. Yeah, because we're solving this. Our final answer is going to say v equals something. We're going to get 2 solutions out of this. The last step is really simple, though. 2 steps. The last 2 steps are really simple. All right, now this only works when you have an equation with factors multiplying and equal to 0, but there's this thing called zero product property that says if you have 2 things being multiplied, like we do, the parentheses are being multiplied here, right? Equal to 0, what must be true about one of those numbers? One of them has to be 0. So either this is 0 or this is 0. So what we do is we split it up into 2 equations. So one of my equations is going to be 3v minus 1 equals 0. Would anybody like to guess what the other equation is going to be? V minus 6 equals 0. One of those is equal to 0. So we set them both equal to 0. And we solve them both, and then that gives us our 2 possibilities for v. So the final step is just to solve those 2 equations. Most of you can probably solve this second one without showing any work. What is v going to be for this second one? V equals 6. And I'm okay with you jumping straight from that equation to here. If you want to show the step, you would write plus 6 on both sides, cancel that out, and you get v equals 6. Bless you. The second equation, the other equation, takes 2 steps of algebra to solve. If you can look at this equation and do those 2 steps in your head and come up with the answer v equals positive 1/3, I'm okay with you jumping straight to that. You don't have to show me your 2 steps. If you can't do that, here's how you would do it with the steps. You would go plus 1 on both sides to get rid of that minus 1. You'd have 3v equals 1. And then how are you going to get the v by itself? Divide by 3 on both sides. That'll cancel, and you'll get v equals 1/3. That's your second answer. So v equals 1/3 and v equals 6 are 2 answers there. Add 1 to both sides and then divide by the 3. And if you're not seeing it already, I imagine after you do a couple of these, you'll be able to jump straight from this equation to this solution without showing that work. And I'm okay with that. Your Algebra 2 teacher next year might make you show the steps, but I'd be okay with you not. So that's one problem, and that's a lot of steps. But we've already practiced all of this stuff over here pretty significantly. So hopefully we can work through this part pretty quickly. The only really new thing is take your equation, split it up into 2 separate equations and solve them. Okie doke. Let's do another one. All right, now this one is not set up as nicely as the last one because it doesn't have that 0 equal to 0 on one side. So the first thing we need to do before we do all of those other steps is we need to get a 0 on one side. I am going to get a 0 over here, meaning I got to get rid of all of this stuff. So let's start getting rid of stuff. How am I going to get rid of this minus 5x? We'll do plus 5x on both sides. And I'm going to line it up underneath the 8 because those are like terms. Now these are going to cancel. How shall I get rid of this plus 6? Minus 6 on both sides. I'm going to tuck this out front because there's no like term to write it underneath. Cancel those out. How should I get rid of this plus x squared? Minus x squared on both sides. And that is a 1x squared, agreed. So that all goes away. And then we're going to rewrite this. Now, when you rewrite it, we're about to factor it. We want to have our x squared first. So we don't want this minus 6 to come first. I'm actually going to wait and write it at the end. So let's deal with the x squared. 6x squared minus 1x squared is 5x squared. 8x and 5x gives us 13x. And my minus 6 over here, I'm going to put in at the end, equal to nothing left over here, which is 0. That's great. That's what we wanted. So we had to do an extra step in this one because we did not have it equal to 0 at the beginning. We had to do a little work to get a 0 on one side. Do you have a question? No? Okay. Pause the side conversations, please. Okay, then we need a factor. So we're going to factor this thing. It's going to end up looking like this. We got to go through all those steps that we just practiced and that we learned on Thursday. So we'll identify A, B, and C. I'm actually just going to jump straight to my diamond or my X this time. What should go in the top of my X? It should be A times C. 5 times negative 6 is negative 30. Thank you. And then B goes in the bottom, that's 13. So do a little work, see if you can find me two numbers that multiply to give us negative 30, add up to 13. I'm thinking 3 and 10. 3 and 10 can't work. Why not 3 and 10? They add up to, they multiply to 30 and they add up to 13. Oh, we need a negative 30 though. Which means one of them would have to be negative, which means they're not going to add up to 13, are they? What was your suggestion, Alex? 15 and 2? 15 and negative 2. Those two multiply to negative 30 and add up to 13. Okay, so we got 15 and negative 2. So let's build a box based off of that. Okay, going back to my quadratic. Our box should contain that 5x squared and the negative 6. Can you remember where those two things go? The 5x squared and the negative 6. Go ahead and put it in there. And then that 15 and the negative 2 we got from our x should go in the other two spots. They should both have an x after them. So 15x and negative 2x. Focus on that top row and do me a GCF here. Biggest thing that I can divide out of 15x squared and 2x. 1. Yeah, how many x's can we get out of them? Just a single x. So 1x again, huh? Well, so it goes. What would I need up top then? Let's see, 5x. 1 times 5 would 5. X times x is x squared. So 5x works there. I think I want a negative 2 here, right? 1x times negative 2 would give us negative 2x's. And in this spot, what multiplies by 5x to get us 15x? 3. Double check, make sure that works to get you the negative 6 also. 3 times negative 2 is negative 6. Yes, it works. So we got a 5x minus 2 and an x plus 3. So that's all old stuff. The new thing today is how do we use that to solve? This is where we're going to split it up. We're going to make two separate equations and solve them both. So we're really close to the end now. One of my equations is 5x minus 2 equal to 0. The other one is x plus 3 equal to 0. Give this a try. See if you can do the steps in your head to solve this. X equals what? I'll give you a hint. It's going to be a fraction. If you have a coefficient and a constant like this, yes, it will be a fraction. The only thing is if this number went into this, because you're going to end up dividing by 5, right? So if this was a number that was divisible 5, then it wouldn't, by 5, it wouldn't be a fraction. Right? If this was a 20, we would do add 20 on both sides and get a 20 over here, divide that by 5, and we would get a 4, so it wouldn't be a fraction. This will be a fraction, though. Think through in your head. If you were to do plus 2 on both sides, you'd end up with a 2 over here. And then you'd have to divide by the 5 to get rid of the 5. So your final answer would be 2 over 5. Now, if you need to show the steps to get there, if that makes you more confident in your answer, then that's fine. But if you can jump straight from that equation to that answer, that's just going to save you time. That's one of our answers. And I bet all of us, I'm hopeful that all of us can jump straight to our answer here. What does x need to be to make that true? -3 minus 3 on both sides, going to get x equals -3. All right, that gets us 2 problems done. I am going to ask you guys to work on the next 4 problems. I'm going to give you about 10 minutes. See how many of those you can get done in 10 minutes. Some of you are going to get like 2 of them done. Some of you will get 3 done. A few might get all 4 done. Okay, try and get at least 2. All right, I'll put answers up here so you can check as you go. Get after it. Ask me some questions. I'll be around to help you out if you have questions. Okay, for the second half of this, there's another way that we can solve these quadratic equations, and this is using the quadratic formula. You're going to be asked to memorize this if you're taking Algebra 2 next year. For this year, this will show up on your final exam, but remember, you get a half sheet of paper that you'll be able to write whatever notes you want on. I would highly recommend that you get the quadratic formula onto your half sheet. Go ahead and put it up at the top of your paper right now, though, so you've got this. So the quadratic formula relies on A, B, and C. We've been practicing identifying those. Do you guys remember the quadratic formula? There's a song that goes along with it. I'll sing it for you. It's going to get really awkward in here. You guys remember this? It goes to the tune of Pop Goes the Weasel. X equals the opposite of B plus or minus the square root. Do you remember this? B squared minus 4AC all over 2A. Good. That's the quadratic formula. Some Algebra 1 classes got this far last year, some did not. I'm going to show you to you. This is one of the easiest things you'll be asked to do that you should have been asked to do in Algebra 1. But for some reason, my students always have this mental block against it. They're like, this is so hard. So this right here, quite literally, is a formula that will tell you what the answer is. That's it. So instead of us having to go through all of these steps here, we could have just taken this A, this 3 here, this -19, and this 6, and just put it into this formula, and it would have given us this answer. So why don't we do it that way? A lot of times this is going to be cleaner. The other reason I have you do it this way is because we went into practice factoring. But that's a valid question. Like if we can always use, and by the way, you can use this for any quadratic. So if we can always use this, why would we ever solve by factoring? Because sometimes solving by factoring is easier. Especially if you're one of the people that has learned like the shortcuts for how to solve this, where you don't have to do all this side work. Yeah, it's easier. But that's all you're doing. You're just taking numbers, putting it into this thing, A, B, and C, and you're coming up with an answer. So let's do one together. And just remember, I don't know why, but my students always moan and complain about this. Just remember what you're doing. You are putting numbers into a formula, and that formula gives you your answer. So let's do this first one. Up here where we got a little space, let's identify A and B and C, just like we did before. By the way, we do have to have a 0 on one side of our equation in order for this to work, but this one already has that. So A is 8, thank you. B is 3, and C is -16. You're doing great so far. And then we are going to put this into the formula, and the formula is going to give us our answer. Our answer is x equals, we're going to get two numbers. X equals. Now, the biggest hint I can give you is that when you do the quadratic formula, set up the formula with blank parentheses before you put numbers into it. If you get in the habit of doing things this way, it will actually go faster for you. You'll definitely be much more accurate. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So set it up with blank parentheses first. That's the same thing that I just wrote up at the top of the page. I just left out all the A's and B's and C's, and I left blank parentheses in their place. And inside of those parentheses, we're going to put 8 and 3 and -16. We just got to get them in the right spot. And for me, when I do it this way, that's really easy because I remember that B goes here and here. B was 3, so we'll put a 3 here and here. A goes here and here. A was 8, so we'll put it here and here. And C goes in the last spot. That's because that's the way. Why does it have to be in that order? Because that's the way the formula works. Put them in a different order, you're going to get a wrong answer. If you're interested, I can show you where this formula comes from. I'll do that in a little bit. But let's just practice using it first. Let's get good at using it, and then I'll show you where it came from. Okay, so let's simplify this. So we got -3, so that's just -3. Plus or minus. Somebody asked me, how do you know if it's plus or minus? And the answer is it's both, right? You're going to get two different answers. You'll do one version with the plus, one with the minus. That's okay. Don't worry about it because we're just, we'll stop. 3 squared is 9, right? And then we need to multiply these three numbers together. When we multiply these three numbers, is it going to end up being positive or negative? We got a -4, +8, and -16. Agreed it's going to be positive? All right, so let's multiply those. If you've got a calculator, feel free. 256 times 2 is, I believe it's 512. Check me though. Is it 512? Yep. And then the bottom I turned into a 16, right? Because that's what 2 times 8 is. And then we're almost there, I think. Well, it depends on whether we can simplify our radical or not. 9 plus 512 is 521. What I'm not sure of is, can we simplify the square root of 521? You guys remember simplifying radicals before? No, we just did it like a week ago. But let's try and divide it by some perfect squares. Give me some perfect squares that I could try to. 521 divided by 9. Nope. I'm not going to try 36 because 521 is not even. Anything that divides by 36 would have to be even. So 25, it's not going to be divided by 25 because it's not, it doesn't end in a 5 or a 0, right? 11's not a perfect square. Let's not be calling people names. What are some other perfect squares we could try? 81. Now, if it doesn't divide by 9, it can't divide by 81 because 81 is 9 times 9, but I can tell you for a fact 81's not going to work because 9 didn't work. How about 121? No, I don't think it's divisible by any perfect square. In fact, I think it might be prime. So so there we go. That's our answer. If you wanted a decimal for this, I would type in -3 plus square root 521 divided by 16. Write that down and then do the same thing with the minus. But we don't need decimals. We'll just leave it like that. That's it. Right. If 11 doesn't work, then 121 is not going to work either. You're right. I didn't need to do that. All right, let's do another one. Now this has got a problem. We can't do this until we do something first. What do we need to do first? We gotta get a 0 over here. So let's get rid of this stuff. Let's do a plus 7x. Now I don't have any place in here to add that, so I'm just gonna add it off to the side. And then we'll do a -1. And make sure you write this in the order you expect to see it. We expect to see the x squared first. So I'm gonna put my 11x squared first, and then my plus 7x, and then my -6. And now we got a 0 on that side. All right. Can you look at that and see what your A, B, and C is without me writing them down? 11, 7, and -6, right? So let's just jump straight to our formula. So x equals the opposite of b plus or minus the square root b squared minus 4 all over 2a. And let's get that 11 and that 7 and that -6 where they belong. Are you making fun of my singing? Thank you. I don't think I go that far, but that's good. That's a compliment. I'll take that as a compliment. My voice is better than cats dying. I'm not going to win the voice. Is that what you're saying? So it goes. All right. B goes here and here. A goes here and here. C goes over here. And we just have to go through this last part's a little tedious, the whole simplifying thing. I'll show you a little trick though. If you've got a fancy calculator, yeah, and you'll have to work it out by hand, but yeah. Oh, sorry. Thanks for that question. Hang on a second, guys. That's a really good question. So you were saying the 7x when I added, since it didn't have like terms, I put it in front. You said shouldn't that go at the front? When I write an equation, a quadratic equation, if it's going to have an x squared, I always want that x squared to come first. So I rearranged it. I didn't put the 7x at the beginning. I put the 11x squared at the beginning. You always want the x squared first. And then you want your x term to come next, and you want your constant term, the one without a variable, to come last. So you want to make sure you put this in the right order so that you get A, B, and C correct. Because A is always the thing on the x squared, B is always the thing on the x, C is always your constant. So that's a really good question. It doesn't matter what order we write those down in. Thank you for that question. Much appreciated. All right, let me show you the shortcut. This isn't much of a shortcut. It's just like take this whole thing in underneath the radical and punch it in your calculator with the parentheses. I'm just going to take this whole thing right here and punch it into my calculator. So I got 7 squared minus 4 times 11 times -6. I just typed, and I'm not dividing it because it's just the inside of the radical. That is 313. And this is 22 down here. And that's it. I think that's my answer. I'm pretty sure 313 is not divisible by any primes. Right, so that's it. So if you've got a calculator, you can make this go a lot faster for you. Once you put it in there, you just type the inside of your radical into your calculator, and that's it. That's the final answer. So can you guys tell me, what do you think? Why do my students complain about the quadratic formula so much? Is it really though? It's like 2 steps. You plug numbers into a formula and then you simplify it, right? So you'd rather do this like 18-step process up here? Okay, that's fine. I mean, that's great. I'm with you. If I can solve by factoring, I'll always try and solve by factoring first. I don't know why. Quadratic formula, I usually end up, not usually, but a lot of times I end up making mistakes. Let's not place value judgment on mathematics now, okay? Okay, questions?
In the quadratic formula, like the skeleton.
Mm-hmm. Yeah.
You already have like.
Yeah, so that's a great question. So in number 9, when we go to put this into our quadratic, it's the opposite of b, plus or minus the square root of all this other stuff, squared minus 4ac all over 2a, right? We're going to put this -4 in for b. What's going to happen when I simplify that? What is the opposite of -4? It's going to turn into a +4. So in my next step, I'll write that as a +4 instead of a -4. That's a great question. What other questions do you guys have? Mm-hmm. If you have an x cubed in your equation, it's not a quadratic anymore, so the quadratic formula does not work. Okay, so mathematicians spent a long time trying to find a cubic formula, and there is no is that true? There is a generalized cubic formula, but it's really, really complicated. But their search for the cubic formula allowed them to find things like imaginary numbers, which you'll learn about next year in Algebra 2. So that is a very good question, and it led to a lot of really important mathematical work. But short answer, we're not going to deal with it because it's way complicated. You're going to have to wait until you get into some really higher college level math classes to deal with cubics. A lot of your solutions are going to end up being imaginary for cubics. We can actually have imaginary solutions for quadratics. And when I say imaginary numbers, that's not like elves and unicorns. There's like a special type of number called an imaginary number. They do exist. They're just, yeah. It's not something that you could count out. Let me give you one word of warning. If those of you who have a calculator, could you type -5.2 into your calculator and then square it? Can you please tell me what the square of -5.2 is? The square of -5.2. That is my favorite wrong answer. Domain error, that should not happen. It is 27.04. It is not -27.04. If you are trying to square a negative number, you must put it in parentheses in your calculator. If you do not put it in parentheses, you're going to get the wrong answer. Think about it. When you square a negative number, doesn't it have to come out to be positive? when you square something, you multiply it by itself. So if it's negative, that's a negative times a negative, which should come out positive, right? So you give me a positive answer, that is correct. Make sure. So I'm telling you this because a lot of times people leave these parentheses out when they're typing it in their calculator, and that causes them to get incorrect answers. Syntax error, you might be using a minus instead of a negative. On the TI calculators, for some reason, a negative, you have to use this button, and a minus, you use this button.
On mine, it's right under the plus symbol, so mine even has a different one.
Yeah. All right, folks, you got the rest of our time here to be working on this. That's a good 20 minutes. I don't want to see anybody packing up for the first 18 of those. Get my attention if you need any assistance.